Okay, we can go over the worksheet, and the first question, we're using game theory because of interdependency. Your outcome depends not only on your own choices, which is true in perfect competition and Monopoly, but on what other players are doing, so you're a small group and really interacting. A dominant strategy is when one player has a strategy that yields the highest payoff independent of what the other player is doing. So you have a go-to strategy, a strategy that gives you a better outcome no matter what they're doing for any one of their choices. What is not true of a Nash equilibrium? Well, this one is true. Given B, A is chosen the highest payoff. So this one is true. Neither wants to choose a different strategy. That's also true with a Nash equilibrium. Both are content. True. And given the strategies of A, B is chosen the highest. That's the best response. That's also true. So this is the one that's false. It's not necessary for both to have a dominant strategy for a Nash equilibrium. We saw that in our very first game with Allison and me. Neither of us had a dominant strategy, but there were Nash equilibria in that game. In the next game where she had a dominant strategy and I didn't, there was Nash equilibrium, so this is false. The prisoner's dilemma refers to a game where both players have a dominant strategy. That's our first criteria, and then a lower payoff than their dominated strategies. That's the second criteria, and we need both, and that's all we need for a prisoner's dilemma. A cartel is firms that work together to restrict output and earn profits. The last question, we have a game, and we need to first fill in the payoffs in this table. So, both have $1,000 revenue if they keep the old price. So we can fill that one in. Let's see. They each have 900 if they both lower the price. So those are easy. Now, if Joe cuts the price, his revenue will be $1,350, and Sam's price remains, it'll be $500. So Joe cuts the price, and Sam keeps the old price, and Sam gets $500, and Joe gets $1,350. Sam cuts the price to 90 cents, cuts be $1,350, and Joe will have 500 from keeping the old price. So there's our game. What do we think is going to happen? Well, we need to find the equilibria and do best response analysis. So if Joe cuts the price, Sam should also cut because 900 is going to 500. 1,350 is better than 1,000. And the same for Joe. Cutting is better than keeping up here and here. So this is actually a prisoner's dilemma. They both have a dominant strategy. Dominant strategies leading to worse outcomes, 900 each instead of 1,000 each. So the pressure is going to be on both of them to cut the price. All right, they're not going to be the ones to keep the price while the other one's cutting and just have 500. They're both better off if they cut the price, regardless of what their other player's doing. So this is a prisoner's dilemma. So let me know if you have any questions about the worksheet or any part of this unit.